When utilizing the hypothesis test of two means, essentially what we're doing is we're looking at two independent groups and we're testing the averages of a characteristic of that group. And before I go through and talk about the mechanics of this, what I'd like to do is I'd like to give you an overview of an example of this. So, for example, let's say we're looking at the average grades of Harvard Community College students. And let's say for some reason that we took a sample of, let's say, 100 non-honors students. So we know that the number of samples would be 100. Let's say for some reason the sample standard deviation produced that the average GPA of those students was 0.49. And let's say that the mean GPA produced that the average was 2.60. Now, let's say for some reason, let's say we took a survey of 50 honors students. And so we know that the number of samples there would be 50. Let's say for some reason we got the sample standard deviation of that group to be 0.35. And let's say that the mean of that group, and it shouldn't be mu, excuse me, it should be x bar for each of those. So let me erase each of these because they are sample means. Apologies. So x bar would be 2.60, and let's say that the average GPA of a Harvard Community College honors student was 3.40. And the question would be, is there evidence to suggest that there's a significant difference in the GPAs of an honors student versus a non-honors student? Now, logically, of course, we know that there probably is evidence for that. Okay. However, we need scientific basis for this. And that's where we'd use this hypothesis test of two means. So we gather a sample, we'd be able to compute the standard deviation of those samples, and then we would use a hypothesis test for that. So let me talk about the outline for this. And much like the other tests, we're going to start by the null hypothesis. Now, the null hypothesis is going to assume that if there's no difference in the means, in other words, they're completely random, there's no influential factor that governs GPA between honors and then general students, is that the null hypothesis would be that the two sample means are equal. The alternative could be one of three possibilities, either x bar 1 greater than x bar 2, it could be x bar 1 less than x bar 2, and then finally x bar 1 not equal to x bar 2. Now at this point, just like we did with the two proportion test, you have to define group 1 and group 2. So we have to define the groups at this stage. If we don't, we might flip them and unfortunately get an incorrect hypothesis. The next thing we're going to do is we're going to collect some variables. All right, so we're going to have some variables for group 1, and then we're going to have some variables for group 2. Variables for group 1 are going to be x bar 1, s1, and n1. X bar 1 is the mean of group 1, sample mean. S sub 1 is the standard deviation, and n1 is the sample size. We're going to do the exact same thing with group 2. We're going to call it x bar 2, s sub 2, and n sub 2. We need to get a significance level. Okay, so we're going to collect alpha. And then the last thing we're going to do with this type of test is we're going to get the t critical value. Okay, so t critical is going to be dependent upon the significance level. Again, if it's two-tailed, we have to split. Okay, so we're going to split if x bar 1 does not equal x bar 2 for the alternative hypothesis. And t critical is going to be contingent upon the alpha level, or alpha over 2, and then the degrees of freedom are going to be n1 plus n2 minus 2. So that's going to be our equation to be able to find t critical. Next thing we're going to do is we're going to set up the distribution. The distribution is going to be the same as what we've seen before. All right, so recall that for a left tail test, we're still using a t-distribution because we don't know the population deviations. Remember, negative t critical is the left-hand cutoff, and the range of values are from negative infinity to positive infinity. And then, of course, in the middle of the t-distribution is the value 0. So again, this is when the alternative hypothesis is x bar 1 less than x bar 2. If for some reason we have a right tail test, same exact distribution, except we're going to have a right tail as the reject region. Negative infinity, 0, and positive infinity are going to be our benchmarks for the endpoints in middle. And then t critical is the value in the center. And again, that's if we have x bar 1 greater than x bar 2. And then finally, we might have a two-tailed test, and this is where we would have to separate, or excuse me, we'd have to divide alpha in half first. So, one moment. So if it was a two-tailed test, just like we did before, we're going to have two tails. We're not going to split the critical value. Okay, the only thing we're going to split is alpha. So it's negative infinity, negative t critical. The value in the middle is still 0. Positive t critical, and then positive infinity. And again, this is for when x bar 1 does not equal x bar 2. And I'm going to insert the caveat here that we have to split alpha before finding t critical. All right. So you're going to draw one of those three distributions. Next, you're going to be able to compute the test value. Right? And the test value is going to be in 3 stages. So here's our formulas for the test values just below here. So first of all, we're going to compute this thing called the pooled standard deviation. And when we get to our next video, I'll show you how to put that into the calculator once we've found it. Once we've found the pooled standard deviation, we're going to find this thing called the estimator of the standard deviation. And then once we have that estimator of the standard deviation, which by the way uses the pooled standard deviation. Okay, so that's why we find the pooled standard deviation first. Once we find that, we can find the estimator, and then finally we can get to our test value. Finally, the conclusion is just as always. If for some reason the test value falls in the reject region, we reject the null, meaning that there is evidence. And then if for some reason the test value falls in the fail to reject region, we're going to say that there is not enough evidence to suggest what is implied by the sample data. So in the next video series, we're going to go through a couple examples of these just to make sure you understand the mechanics.